All right, new functions from old. So transformations of functions. Okay, so you may remember from college algebra, we can shift the graph up, down, left, right, stretch, compress, both horizontally and vertically, or reflect about the x or y axis. So you should know all of these transformations. So let's say that I want to graph this function. We might want to put it in the form of a parabola's basic vertex form that we learned in college algebra, and that involves completing the square on this guy. So what we're going to do here is we are going to say x squared minus 2x and leave plus 4 on the outside, and we're going to take half of the negative 2, which is our b term. So we're going to take half of that, we get a negative 1, and we're going to square it. B over 2 squared would be negative 1 squared. That's a positive 1. And we're going to add that in here. And if we add it, we've also got to subtract it. Okay. So now this part we group together, and that always factors into x plus whatever your b over 2 term was. So in this case, negative 1 squared. And then combine these like terms. Plus 4 minus 1 is plus 3. So this is where my vertex is now located. Notice that we are moving right 1 unit and up 3 units, right? So my vertex is at positive 1, positive 3. So I'm going to draw at positive 1, positive 3, the vertex, and then we know that because we have a positive coefficient in front, the parabola opens up. Now it's easy enough to plug in 0 for the x's and get our y-intercept. It's at 4, right? So right here at 4 is where our y-intercept is. And so we draw our parabola opening up that way. Notice that the domain of this guy is all real numbers, and my range, the lowest we go is that 3. So it's 3 to infinity. All right, I want to graph 1 plus 2 sine of 2x. So you may remember that this gives me a vertical shift up. This is a stretch. So in terms of the trigonometric functions, we referred to that as affecting the amplitude. And then the 2x, the 2 affects the period. So what we learn to do in trigonometry is to take the inside of the trig function and set it equal to 0 and to the length of the period, which for a sine function is 2 pi. So then divide by 2 on both of these, and we get x equals 0 to pi. So that's the new period of this function. So what that means is that as x increases, that didn't draw very well, did it? Let's try that again. Oh, my eraser's not working either. What did I do? There we go. Let's try drawing that one more time. Why can't I get rid of those? Okay, we'll just go off to the side from it. All right. Okay, so as we go from 0 to pi, we complete one full period of this function. So we take the length of the period, which is pi, and we divide the length of the period by 4, always by 4, and that's going to give me the tick marks that I put on the x-axis. So in this case, if I take the length of pi, which is my period, and divide by 4, I get pi over 4. So at 1 pi over 4, we have the first thing happen, 2 pi over 4, pi over 2, and then 3 pi over 4, and then 4 pi over 4 finishes the period. So in this case, we have a sine function. We know that what sine does is it starts from 0, goes up to a high, back to 0, to a low, and then back to 0. Now, on the regular sine function, that would go from negative 1 to positive 1, and it would look like that. But ours is stretched by 2 and shifted up 1. So we're going to stretch by 2, so we're going to go all the way up to 2 and down to negative 2. But then we're going to lift it up 1, so we're going to go to a height of 3 and a low of negative 1. And these zeros are up 1, so the zeros are now occurring on the y equals 1 value. We go up to a high of 3, back down to a low of negative 1, and then up. That's one full period of the sine function. Now extend to get all the rest of the periods in. All right, we want to graph x squared minus 4 in absolute values. Well, if I were just graphing y equals x squared minus 4, I would say that this is a shift down 4 units on the graph of the parabola. So that would look like this, where this is a negative 4 and 2 and negative 2. What does absolute value do? It takes everything and makes it positive. So these that are below the x-axis are going to flip up to above the x-axis. So what that's going to look like is, right? Those are parabola shapes, right? This is negative 2, that's positive 2, and that's 4, okay? All right, now combinations of functions. I can add, subtract, multiply, and divide my functions. So let's talk about adding and subtracting first. If I have f of x and g of x, then adding them, we just add the individual functions. Subtracting them, we would subtract the individual functions. The domain is what they have in common. So if my f of x is square root of x, then its domain is 0 to infinity. Remember, just set what's underneath the radical greater than or equal to 0. And then g of x being 2 minus x, its domain would be negative infinity to 2. So if we look at this, 0 to infinity is all of this stuff, and negative infinity to 2 would be all of this stuff. So what they have in common is the overlap right there. So 0 to 2 is the domain of the new function. Same with division, but we also may have to exclude anything that makes the denominator 0. So if I have x squared and x minus 1, then f divided by g would just be x squared divided by x minus 1. We'd have to exclude x equals 1 from the domain. The other way we can combine functions is through composition. Composition is where you put one function in as the variable in another function. Here's a diagram to illustrate that process. In order for this to be defined, what goes in has to be defined. So we start with the domain of g of x, and then what comes out has to be defined. So we then further reduce that domain by anything we need to make sure that the output's defined. So for example, if I have x squared and x minus 3, I want to find the composite functions, f of g and g of f. So f of g, we're plugging g inside. We plug x minus 3 into the f everywhere we have an x. So that would look like x minus 3 squared. And if I want g of f, then I'm plugging the x squared everywhere in here that I have an x. So that would look like x squared minus 3. So these are the way these two different compositions work. Now notice that x squared has a domain of all real numbers, and the linear function x minus 3 has a domain of all real numbers. So the domain of the composition would be all real numbers.